Okay, now we're going to do a few examples for graphing transformations of sine and cosine. So here's our next example. Y equals -3 cosine 2 theta minus pi over 4 minus 1. So we'll first work with all the basic characteristics. Midline, of course, is y equals -1, which means we can actually show that on our graph. There's our midline, -1. The amplitude is 3. It's 3, not -3. It's 3, which means our maximum will be 2. So we can graph that. There's our 2. And we can show our minimum of -4. And we'll draw our -4. So again, we could stop at this point and begin to create the coordinates for our 5 points. So there's our parentheses for the 5 points. And because this is cosine and negative, well, cosine negative starts at the minimum. So we go from the minimum to the mid, to the max, to the mid, back to the minimum. So if I show that on my graph, my first point will be at the min, then the mid, up to the max, to the mid, back to the minimum. Well, we can see our values are on these 3 lines. So the minimum is -4, so I'll place that. Mid, -1. The maximum, 2. Back down to the midline, -1. And down to the minimum, -4. So I've got all my y values for my 5 coordinates. Let's pick up where we left off. Period. 2 pi divided by b, or 2 pi divided by 2 is pi. Phase shift, -c, so pi over 4 divided by 2 gives me pi over 8, which means we're shifting to the right pi over 8 units. Now we can find out theta. Again, the intention will be drawn toward the stuff or the values inside the parentheses. The generic format is left bound less than or equal to whatever's inside the parentheses less than or equal to right bound. The left bound and right bound is determined by what trig function, cosine. You'll see in future lessons that the left bound and right bound isn't always 0 pi and 2 pi. So it depends upon the trig function. Cosine, we know, starts at 0 pi, ends at 2 pi. So now, substituting the expression inside the parentheses, let's solve for theta. First thing we'll do is we'll add pi over 4 on all 3 sides. The arithmetic gives us pi over 4 less than or equal to 2 theta less than or equal to 9 pi over 4. To get theta by itself, divide all 3 sides by 2. Pi over 4 divided by 2 gives us pi over 8. This gives us 9 pi over 8. And so what this does for us, it transitions from our original left bound and right bound being 0 pi and 2 pi to the new transformation. The new left bound is pi over 8. The new right bound is 9 pi over 8. And if we just pause for a second, this is like 1/8, 9/8. The distance from 1/8 to 9/8 is 8/8, or just pi. And look what we have here. The period was pi. So all of these numbers are beginning to match up. So now we find our other 3 thetas. We average our 2 left bound and right bound. That gives us an average of 5 pi over 8. We average the pi over 8 and the 5 pi over 8. That gives us 3 pi over 8. And we average the 5 pi over 8 and the 9 pi over 8 to give us 7 pi over 8. 1, 3, 5, 7, 9. So everything is matching up. So now we can just substitute those thetas. Our thetas are pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8, and 9 pi over 8. Simply place those as our x coordinates. Our minimum as an actual. So there's our minimum. It's located at the pi over 8. There's our mid. It's located at the 3 pi over 8. There's our max, 5 pi over 8. the mid back at 7 pi over 8, and the minimum 9 pi over 8. So the graph helps see where the different coordinates actually come from. We can begin now to go backwards, fill in the rest of our points. Just finish the pattern. Graphing it, there's our curve. -3 cosine 2 theta minus pi over 4 minus 1. And again, you can't see from this graph, you really can't see any of the transformations because all of your graphs will essentially look alike because they're all being drawn within the same confines. But if I go to the calculator, and it will show specifically. So there's our original cosine theta. If I show, here's my second one. There's the one that we just found. So you can see the actual transformations. If I plotted my points, there's the 5 points. So we can see it did shift. Well, first of all, it did reflect. There's my original starting, and it reflected. So it reflected, and it did shift to the right just a bit. And if I actually saw the labels of my 5 points, these are all the points we found earlier. There's the 1/8, 3/8, 5/8, 7/8, and 9/8. So just to illustrate that the graph does actually match the values we have in the PowerPoint. Alrighty, we'll do one more example. Now we got y equals -2 sine theta over 4 plus 3 pi over 4 plus 3. So let's start with the midline. Midline y equals 3. Let's graph it. There's my 3. My amplitude is 2. It's 2, which means my maximum is 5. There's our maximum plotted. Our minimum is going to be 1. So let's plot it. We've got enough to start our 5 coordinates because now we have -2 sine. That means sine, yes, it will start at the midline, but it won't go up to the max. It'll go down to the min. Everything is reflected. So it's mid, min, mid, max, mid. So let's go find where those points are. We can plot it. There's our mid, min, mid, max, mid. So we've got our values ready to go. So mid was 3. There's our y coordinate. Next, the min, 1, y coordinate. Mid, back to the 3, up to the max of 5, back down to the mid of 3. So let's go pick up where we left off. Period. 2 pi divided by b. 2 pi divided by 4 gives us 8 pi. Phase shift, -c divided by b gives us -3 pi, which means we're shifting left 3 pi units. Now, to focus on theta is everything inside the parentheses. Set up my format, left bound, right bound, whatever's inside the parentheses. And again, the focus is sine. The original left bound of sine is 0 pi. The original right bound is 2 pi. Again, there are other trig functions that don't start at 0 pi and don't end at 2 pi. So let's substitute what's inside the parentheses. Let's solve for theta. To get theta by itself, we're first going to subtract 3 pi over 4 on all 3 sides. Arithmetic gives us the -3 pi over 4 and the 5 pi over 4, leaving us with theta over 4 in the center. To get theta by itself, we'll multiply everything by 4, leaving us with a -3 pi is less than theta. It's less than or equal to theta, less than or equal to 5 pi. So we have our new left bound and our new right bound. There's our left, there's our right. Before I go forward, let me just make sure everything is fitting. From -3 to +5 is a distance of 8. Our period was 8 pi. So everything is starting to match up. So it's time to do average, average, average. Average our left and right. That gives us pi. Average the -3 pi and the pi. That gives us negative pi, and average the pi and the 5 pi. That gives us 3 pi. So now we have our 5 thetas, negative 3 pi, etc. Simply substitute those values for our x coordinates. There's our midline. The mid is at negative 3 pi. The min down here is at negative pi. Back to the mid is at pi, because I'm moving horizontally now. That's why I'm choosing these values. 3 pi, and of course, at the 5 pi. There's our 5 coordinates. Of course, we fill in the back portion. There's our max, mid, min, mid, and we can graph it. So that's our graph. I'll go to the graphing calculator just to show what the actual transformations look like. There's our original sine, and when we turn this on, ooh, look at that. So let me munch out. So now we can see the entire graph. First thing I'm going to point out, we had a period of 8 pi. So when I label it, so from here to here, it's supposed to be a distance of 8 pi. Well, I notice here it's like negative 3. Hey, that was our left bound. Negative 3 pi all the way to 5 pi. From negative 3 to positive 5 was a distance of 8 pi. Also, I can see started at the mid, went down to the minimum. So everything is matching up. So with the red, we can easily see the actual transformations, the horizontal stretching, the vertical shifting, the reflecting about the x-axis. And if I label all my points, they have all the coordinates that we found in the PowerPoint. So there's 2 separate examples. Hopefully this helps you out with doing the practice.